So I think we can't wait anymore, right? I don't know what you have in an hour or so, but let's try to make it quick. Uh, Welcome everybody to Munich.NET Meetup, another event of this user group. Unfortunately, still virtual, not real, but yeah, we all hope that soon enough this will change. Now, this is me. You can find me either in my Twitter, usually that, or anywhere else. And I'm marking this because I am actually recording this event. And I don't know, maybe some of you object if you your name might be visible. If you ask something, you might be visible there. If you object, or in any case wanna change that, wanna blur you out or something, don't hesitate. Reach me here in my Twitter or through the meetup.com platform, and we will do everything you want. Now, what we have today, Maria with us. I don't know if I should call you Maria or Anastasia, or I mean, what is better? Let's stick to Maria because it's easier anyway. I think, at least I thought of many times of making my home a smart home, changing to a smart home. Adding a system that will monitor and control various properties, lighting and appliances and climate, entertainment systems, even security systems, access control and stuff. I know that there are ready-made out there in the market, but we are developers, right? And we have Maria with us to help us build our own IoT systems, at least make the first baby steps. Maria, isn't it?
Yes, of course.
I'm very happy we have you here today. I will. We can start in a minute. Just one question. How would you like questions? Would you like me to gently, kindly interrupt you, or would you accept questions at the end? How do you plan this to do?
I think the first one is better.
Okay, I will try to do my best and check for pauses and then interrupt you to ask any questions from people. And you guys, you can write your question in the how is that called, in the chatting thing we all have here. You can find it. I think there is also a shortcut. Let me check. Alt and H. Yeah. Then you can chat. You can ask anything, and I will check it, either me or Maria, and we will answer you. So I will switch off my camera just to save some bandwidth. And Maria, the virtual stage is yours.
Thank you very much. So I will share
Stop
my screen.
sharing because you can't. Sorry for that.
It's okay. I think that you can see my screen.
Yep, all good.
Perfect. Good evening from me too. I hope you and your families are well and healthy with all of this COVID situation. Thank you very much for inviting me to speak at this event. I'm very happy for this. I am Maria. I am studying computer engineering and informatics here in Greece. I'm also a Gold Microsoft Learn Student Ambassador, and I am a robotics teacher for 4 years. My presentation today, it's beginner's level, so it's okay if you are not familiar with IoT, and is addressed to anyone who wants to learn what IoT is, but also to start building IoT systems. So together we will see what the IoT is and where we encounter it, how someone can start, the must-haves that he or she will need, what Arduino, Raspberry Pi and Azure is, and how with this and some sensors, of course, we can build our own IoT system. So let's get started. First of all, Internet of Things. is the communication network of many devices, as well as any object that incorporates electronic means, software, sensors, and network connectivity, of course, to allow data communication and exchange. Simply, IoT is the connection of all the electronic devices to each other as a local area network, or with the ability to connect to the internet. Now, the term things is not strictly associated with the certain projects. It refers to a wide variety of devices. The main feature of all of them is the connection between each other in order for the user to be able to control them from a computer or a mobile device. When we talk about IoT, we refer both to machine communication. For example, a sensor realizes that it's night and sends a signal to the shutters to close, as well as in human to machine communication. For example, a person via his cell phone closes the shutters. This animation is me, who wants to connect more and more things with the internet. Why IoT now? Why did I choose to deal with IoT? First of all, because it's fun to convert whatever you want into a smartphone. Secondly, we encounter the IoT more and more in our daily lives, and this is because devices that integrate the IoT, on the one hand, they help us in our daily life, and in the other hand, they help us in jobs that will be very, very difficult to take place without it. For example, many homes now have different IoT devices, such as thermometers, alarms, but also toothbrushes and other small items. Excuse me. Many homes, however, has a central brain that controls many elements of the home, such as windows, doors, shutters, etc. But in addition to our daily lives, the IoT helps in science such as medicine. It's very useful, for example, for the patient who has a device that measures some values for a disease and for his doctor to be informed automatically. It's slowly beginning to enter the cities in which live, but IoT is even on us. In the clothes, accessories, we wear everywhere. As you can see now, the second reason that I love IoT is that, as you can see, the total installed base of Internet of Things connected devices worldwide is projected to amount to 30.9 billion units by 2025, a sharp jump from the 13 billion units that are expected this year, 2021. As we know, when it comes to data transfer and storage, we need to take the necessary measures to protect them. I think that you can understand that, especially in the Internet of Things, it's very, very important to protect our data and our systems, because violating them can be very, very critical. Think about what could happen if someone violated the system we have in our house. He could break into the house or have information about a lot from us. That is why it's necessary to use a cloud system that is very, very reliable, such as Microsoft Azure. Microsoft Azure is a cloud platform that has more than 200 projects and cloud services designed to help you bring new solutions to life and to solve today's challenges. You can build, run, and manage application across multiple clouds, on premises, and at the edge with the tools and framework you like. And we will see more about Azure later. I think that we have some questions or not.
No, no, just hello to everyone.
Okay, okay. So, how to start now? Let me tell you how the idea of today's presentation came about. One day, a fellow student called me and said he wanted to build a smart system, but he didn't know what to buy and where to start. And so I saw that this topic is probably interesting. So, these are the things that you must have to start an IoT system. You need a microcontroller or printed circuit board, PCB, sensors, breadboard and cables, basic knowledge of electronics, basic knowledge of programming, Wi-Fi connectivity, a gateway, a server, and very, very patience. Let's go to see them in more detail. Microcontroller, as you can see, is a small computer on a single metal oxide semiconductor. It's a very difficult word. That contains CPUs and programmable input-output peripherals. But nowadays we use for our IoT system PCBs, printed circuit boards, like Arduino, to processing all information by sensors, etc. For the needs of this event, we will use Arduino because it's a cheap solution and has a very good community that is very, very helpful for someone who is just starting out. Arduino is an open source electronic design platform based on flexible and easy to use hardware and software. There are several types of Arduino, but today we are using Arduino Uno. Arduino's microprocessor gives us a number of gates that can be used either as inputs or as outputs in our circuits. The Arduino Uno, as you can see here, has 14 digital input-output ports or pins and 6 analog input pins. The 14 digital ports are named with numbers from 0 to 13, while the 6 analog ones with the letter A followed by a number from 0 to 5. At the output, the pins can give 0 up to 5 volt voltage. Now, of the 14 digital ports, 6, and in particular 3, 5, 6, 10, and 11, are also PWM ports, pulse width modulation, which means that they can simulate analog outputs. And finally, with the board, I can tell that the code of Arduino is C-like code and easy to use, it's easy for coding. In order to choose the right PCB for you, you have to think about how much space it should take and how many peripherals it should have for your project. course, we also need sensors for detecting or measuring a physical property, breadboard and cables to connect the elements. Those two are so important, but we often forget to put them on our shopping list. So uh, if you want to make a project, you have to put them in your shopping list. Breadboard is so important for the construction of temporary circuits and do not require any welding. Basic knowledge next of electronics, like how breadboard works, how electronics work, etc. Basic knowledge of programming. I think that we all know, uh, uh, we all have a basic knowledge of programming. And of course, internet connection to send the information to the internet. On PCBs that do not have a built-in Wi-Fi chip, as Arduino, we have to put an extra microcontroller for Wi-Fi connectivity. I have one here. It's very small. Next in our shopping list is a gateway, as a Raspberry Pi, which receives data from all the boards and uploads it to the server. I use the Raspberry Pi because it's a low-cost, credit card-sized computer that plugs into a computer monitor or TV and uses keyboard and mouse. It's a capable little device that enables people to explore computing and to learn how to program in language like Scratch and Python. It's capable of doing anything you'd expect a desktop computer to do, from browsing in the internet and playing high definition video to making spreadsheets and playing games. What's more, the Raspberry Pi has the ability to interact with the outside world and has been used in a wide area of digital maker projects. Raspberry Pi has also a very good community that's very helpful. Next, we need a server that accepts all of our data. For security reasons, I use Microsoft Azure, as I told you before. Microsoft Azure has the advantage of multi-layered security across physical data centers, infrastructure, and operations in Azure. With this, you can rely on a cloud that is built with customized hardware, has security controls, integrated into the hardware and firmware components, and added protections against threats, of course. There are a huge team of cybersecurity experts that work together to help safeguard your data in Azure. Microsoft has entered the IoT sector many years ago with a strong cloud-based offering. Using pre-configured modules, which enable a rapid deployment of an IoT solution. The service includes device-specific SDKs for Visual Studio, support for Windows-based and Linux-based devices, and the cloud-based service, which can quickly and reliably scale from a few sensors to millions of simul another difficult word simultaneously connected devices. The main services, as you can see here, is Azure IoT Hub, IoT Central, and Azure Sphere. Let's have a look now at some of the key services in the Azure IoT. Azure IoT Hub for the beginning. Azure IoT Hub provides secure and reliable communication between our IoT application and the devices it manages. That is, Azure IoT Hub provides a cloud-hosted solution backend to connect virtually any device. Through the Azure IoT Hub, you can see various information to monitor your system and make your own custom solutions for how you want this to look from scratch. Azure IoT Hub provides us with an extremely safe and reliable communication between of the application and the device it manages. Allows the two-way communication, as you can see in this picture, is a platform as a service solution, integrates with many Azure services that is extremely important, and excuse me, has many programmable SDKs for popular languages like C, C Sharp, Java, Python, Node, JS, and finally supports multiple protocols like HTTPS, MQTT, etc.
Maria, can I ask a question? Not me, actually.
Of
A
course.
question from Abdel Mahid. He's asking if using a cloud service like Azure is secure for sending data in an IoT system.
Of course, a cloud service as Azure is very secure. This is why I prefer Azure, because it's very critical to secure our data. So when you prepare your IoT system, you have to choose a cloud solution that you are safe. You are sure you are safe. So this is why I prefer and I use Microsoft Azure. I don't know if I answered your question.
Yeah, I mean, I think Abdel Mahid can come back with another question, but I think in any case, Azure is secure because it has all these patterns to detect any fault injections or anything, any kind of attempt to mess around with your data. So it's not only that you're using Azure as you know it, but because many people use it, and through this, through analyzing all this data, it's easier to understand when there is an attempt to inject or anyway infiltrate in your data.
Nice. So I am continuing with IoT Central. IoT Central is similar to the Azure IoT Hub, with the difference that IoT Central is it's not a custom solution. This solution offers you communication with your devices too, but has specific templates. It's essentially built on the Azure IoT Hub. So it provides us with an extremely safe and reliable communication between the application and the devices it manages to. Allows two-way communication as well, but is a software as a service solution. Provides specific templates, as I told you before, and for this reason, it doesn't require deep technical knowledge. Now, Microsoft Azure Sphere is a solution for creating devices with high security. Azure Sphere is a secure end-to-end IoT solution which contains certified chips and Azure Sphere OS based on Linux, and of course Azure Security Service trusted device-to-cloud communication. Azure Sphere is integrated into the Microsoft Azure platform so that it can use its services. It consists of three main components, as you can see. Cloud security, a secure microcontroller units, MCUs, and a secure operating system based on Linux. Azure Sphere certified chips include built-in Microsoft security technology to provide connectivity. Azure Sphere OS adds layers of protections and ongoing security updates to create a trustworthy platform. Azure Sphere Security Service brokers trust for device-to-cloud communication, detects threats, and renews IoT device security. And Microsoft security experts monitor emergency threats and design updates. Azure Sphere can be combined, of course, with Azure IoT Central. And as you can see, with Azure IoT Hub. Last but not least, we need patience because when it comes to do with both electronics and programming, a lot can go wrong. And now, in this slide, you can see how the final system works when we connect all of these components. Sensor, first of all, detect a physical property and send it to microcontrollers, aka Arduino. The Arduino sends this data to the gateway, for example, Raspberry Pi. And finally, Raspberry Pi sends the data to the Azure IoT. Thus, we can inform about this data from our mobiles or from our computer. For the rest, there are some very helpful websites here. Of course, Microsoft Learn. There you can find very important information for Azure and Azure IoT. GitHub, of course, all we know GitHub. And the other three websites is more for makers. SparkFun, Instructables, and Adafruit. And I want to tell you a fun fact about Adafruit. This company has named after Enda Lovelace, who wrote the first computer program. And since we are not many women in the field of technology, I wanted to mention it to to motivate other girls and women to get involved. Next, there are many simulators on the internet, and because of the COVID situation, I want to mention that there are many simulators, so you can use many microcontrollers even if you haven't any of them. It is also very useful for distance education, and this site search forts have a huge amount of simulators, so you can write down the site to visit it if you want. Another site for simulation I want to tell you about is Make Code by Microsoft, and is perfect for IoT educators and parents. The kids love it. So we can continue with a small project. And we want now to build a home appliance which informs us if someone breaks into our house. So let's find out what we need for make this project. First of all, we need a buzzer or something to something that makes sound to inform us if someone, for example, breaks into the house. Buzzer makes sound in tones, and in this picture you can see how buzzer connects to Arduino. One pin goes to ground, and the other pin goes to some input pin. I have to tell you now that I don't remember by heart any information, but I can read this information by the manual of the sensor, for example, or from the internet. Next, we have ultrasonic sensor that measures the distance of a target object by emitting ultrasonic sound waves, and converts the reflected sound into an electrical signal. Ultrasonic waves travel faster than the speed of audible sound, the sound that humans can hear. A fun fact about ultrasonic is that works like bats, and that is an example that many times technology imitates nature, and I find it so nice. There are some specifications here about this sensor, as you can see, and this is how ultrasonic connects to Arduino. Again, one pin goes to ground, other goes to 5-volt voltage, and we need one pin for trigger and one pin for echo. Next, we have a relay. Relay is an electrically operated switch. For our project, it is useful when ultrasonic, for example, detect motion. Relay could turn a lamp, turn on a lamp so that the thieves are frightened and believe that someone is in the house or something like this. Um, this is how relay connects to Arduino. Again, ground, 5-volt voltage, and one pin for information. We need a keyboard too to press out our code and turn off the alarm. Keyboard works as like matrices. And how is this is how keyboard connects to Arduino. Now we have we also need the Wi-Fi module to connect our system to the internet. There are many specifications here because it's more complex element. It is again, so this is, sorry. And in the next slide, it's how ESP connects to Arduino. Warning here, ESP takes 3.3 volt voltage and instead of 5-volt voltage. This point needs a lot of attention because the board may burn if we put 5 volts.
Can I ask something here? Why do you connect it? Is this the other part in the middle, the gray one, like this bread something? I don't remember the name. You don't connect it directly to Arduino, you connect it through another gray thing there.
This is because it's very simple to connect it to breadboard because we have some connections. How to to explain to you? There are many inputs and outputs. I can show you here. If I connect it directly to Arduino, the pins may not
be enough.
Be enough, thank you. Yes, so we have to use breadboard.
Okay, so if I understand it correctly, you might want to connect, of course, more than one to ground or to 5 voltage. So you can't connect all to the same pin of Arduino directly, but you're feeding this ground to this breadboard. Breadboard, and then you know somehow when you're feeding this blue line anyway, I don't know, to a specific pin here. How do you know which? I mean, I don't know. Let's assume this pin is the blue pin from Arduino is the, I don't know, A5. How do you know that the export is there? I mean, this breadboard thing, how it's working, I mean.
Yes, I can explain to you. Because I'm from Polytechnic school, I think that it's basic knowledge, but I had to explain it before. Okay, so I tell you how, and then I can show in camera too.
Yep.
Aside from horizontal rows, breadboards usually have what are called power rails that run vertically along the sides. Basically, I have a smaller one. I don't know if you see. The first line has a cross and it's red. It's better to use for the power, and the blue one uh, down here, it's for ground.
Got it. So they are
Yes.
sort of predefined, let's say.
Yes, and there are numbers here. I don't know if.
Yeah. I can remember from the previous slide that had numbers like a matrix, A4 or something.
And there are some letters.
Yeah.
So I don't remember if I have in the previous slide how
I
it
think you did.
works.
I think you had the image of a breadboard.
Breadboard, yes. Actually, the name of breadboard is from actual bread, because in uh, in the past, I think that use bread for this.
Actual bread? What bread?
Yes. Oh, this slide. Um, so as you can see here, the number is like the same hole. So if I put a pin in the same number, for example, now 55,
Yes.
and down 55 too, it's like I have
Contact there.
contact, yes. But now if I put this pin to 60, it's it
They are not communicating.
yes, yes, of course.
Got it. So it's per number, per row, let's say, that they are sharing. Okay, got it. So you have like in this breadboard here, you have like 30 possible inputs, as I get it, right?
Yes,
And you can, okay, got it, okay.
But in this one, it's 60. 60,
Smaller.
60 something.
It's bigger, yeah, okay.
Bigger, yes.
Okay, thank you very much. Sorry for the interruption. I think there are some discussions going on over here. I don't know if there are any more questions. Is the green input line still 5 volts output? No, there are, I think.
Where?
Well, there is a question starting from 50 saying that asking if the green input line is still supplying 5 volts output, probably in that last slide. Was it not this one?
Give me this one, or
I don't know. Can
or
you?
this one maybe.
Yes, probably this one. Probably this one. And they're asking if the green input line supplies 5 volts output, where it's connected right there. I can't read it. Because it seems 3.3, right?
Yes. This chip, this microprocessor, it needs 3.3. So if we put 5 volt, we may burn this.
Overload it, yeah.
Yeah.
Okay. I mean, the guy's saying that he cleared things out anyway, so we can proceed.
Okay.
Sorry everyone for the interruption, but I'm quite a newbie at this, so yeah, I have some newbie questions.
No. Basically, I thought that I didn't know to explain about breadboard or not because of because I am in a polytechnic school and
Yeah, you assume some
we
prior knowledge, and that makes sense. But I mean, let
yes.
we can leave questions guide us or guide you actually.
So it's good for me too to know that that many people who are into coding maybe maybe didn't know this information. So it's good to me too.
Yeah, well, I don't know how many I know I didn't, so I don't know. Anyway, let's move on. And
Mhm.
yeah, as I said before, questions will guide us where we want to jump in details.
Okay. So this is an LCD display and it's useful for showing us information about our system. Um, this is how it connects to Arduino. It's a little more difficult, so this slide explains, I think, perfectly why we need breadboard. And our system is ready and looks like that. Or, oops, give me 1 minute. Or looks like that. So I think that I have time to connect Arduino to my computer. This is the code. Um, I think that I can explain to you some of these, some basic information about this code. Give me 1 minute. I think that you see the code, right?
Yep, correct.
Perfect. So when we start a new project in Arduino and in um, in IoT, um, um, excuse me, I I'm thinking how to explain to you. There are two functions from the beginning. Setup that is here, as you can see, and set up a function in which we put all the commands that must be run once when our unit is activated, when we give power, or when the existing reset button is pressed. So this is the first um, um, loop function.
So this is like an entry point for running everything or just the setup.
Um,
You're not calling anything more than that. You're just setting up things, right?
yes, I explain later
Okay.
more. To tell you now for the void loop, that is the second loop we write in our project. The existing commands uh, will run when it reaches the end. The loop function will be activated again and again and again. So in the setup function, we put the initialization, and in loop function we put our main code. So these are two libraries. The first one is for the keyboard, for this, and the second one is for the Wi-Fi module. I can tell you later, maybe, or now, how we can put libraries in our code. There are two ways. Excuse me, my voice. The first way, we go here, include library, and we go to manage libraries, and then it will open. Where are you? No, it's a little bit slow. It will open the library manager. So we search here what the library we want. Now it updates libraries. Okay, for example, Wi-Fi. Why? It's a little slow. Wi-Fi, and there are many libraries here. The other way is to go here, but we can search on the internet the library that we want and download it as a zip file, and then the Arduino IDE make all the work for us.
So to make a step back, because I'm not, this MSCP comes with an Arduino, or you download it from somewhere?
Okay, MSP is the name of my code. So
it's not the
yes,
environment name.
the environment name is Arduino IDE. And if you visit the Arduino site, you can find it and you can download it for your computer. And in Arduino site, there is also a forum that it's very helpful. It's a huge amount of information there. So you can program from the Arduino IDE, or you can program from VS Code, Visual Studio Code, or in any IDE you prefer.
I guess there are then some kind of drivers to connect with Arduino and send the code.
Yes, but in my diploma thesis, for example, I use VS Code because I am more. It has more, I think. How to tell it? More functions. So I had to download some libraries there, and it was very easy. But if you are starting now, you can download the Arduino IDE. That is very easy, and there is many information in the internet for it.
Super, thank you.
So another information for the ID. Okay, this is about our project. I want to show you. Give me 1 minute. Um, yes, here. When you're starting with Arduino ID, you have to to tell it what board you're using. Oops, this is wrong board. I don't know how. Okay, so I have now Arduino Uno. For example, for my diploma thesis, I have this board. It's the STM32, and if I want to put this board, I have to find which board is for this board. So now we have the Arduino and programmer Arduino ISP, and the other tricky one is that the port. I think that every time I connect my Arduino in my computer, uh, I upload the program, and then the program didn't upload, and every time I have wrong port. So you have to check it. It's very easy though. It's not something that you have worry about. After our libraries, we have defined our pins. And if you remember from the presentation, I have one picture of every sensor, and I saw how I connected to my Arduino. This is why I want to know in which pin sensor connects with Arduino. For example, buzzer has ground, black for ground, red for VCC for 4 volts, and then this this blue pin is for signal. This blue pin goes to 11. Yes, and as you can see, I have defined my buzzer pin as 11. Relay pin as 10, echo pin from ultrasonic 12, and trig pin for ultrasonic 13. These two is for the keyboard. It's a initialization. This two is for ultrasonic, and this is for Wi-Fi, but it's here I have to put the name of my Wi-Fi, and here the code of my Wi-Fi. So Arduino will have the information to enter my Wi-Fi. This is for keyboard 2, and this for the keyboard. I want to continue with the void setup loop. Here we have defined our inputs and our outputs. For example, um, the relay, its output, it will not um, send some information to the Arduino. The Arduino will send the information to open or close the relay. Buzzer, it's output too, but echo pin, it's input. It's for receiving the information from the nature, if it's if it's receive or not data. This line, it's very important. It's about it's for beginning the serial communication at the band rate of this number, and I can change it from where it is. I always I think that it's here, but I don't find it now. No. It's okay, but you can change this number. It's not necessary, of course. Okay, I can't find it
Serial
now.
monitor. I think 50 suggested that.
Serial monitor, it's this, and it's when we maybe yes, it wait to connect my Arduino. This is why I can't find this number. So in a few minutes we can see it. But it's this line. It's very important. Then we have our main code, and okay, this is for these lines are for to clear the trig pin by setting it low, as you can see. Okay, these are to trigger the sensor by setting the trigger pin high for deca for sorry for 10 microseconds. I want, okay, here, yes. I wanted to tell you that I'm for ultrasonic. There is a mathematics way to find the distance, but it hasn't know it by heart. I Google it and I find out that this is the way to make the duration into distance. So with this line, we can find the distance. With these lines, we can make to show to our serial monitor. You will see it in a few minutes. And what else I want to show to you? Yes, here for our to test our projects, I make an if loop, and I I tell to Arduino that if this distance is less or equal um, to I my
Andy.
brain 20, yes. Oh, the Arduino will print this message alarm, and then the relay will open to turn on the lamp, for example, and then the buzzer will make a tone to inform us about uh, this distance. So I have this cable, and I am going to connect to my system. Sorry. Something. Okay, this is for verify, this is for upload. I had verified it before, so I upload again my code. Compiling, and I can open the serial monitor. Yes, oops, sorry. I'm trying to. The compiling, it's not ended, but Arduino has the code from before the event. But we can wait a few seconds to. Oops. Ah, again, I have wrong port. Here. Oh no, I haven't. I don't know. One more time. We have to wait. I don't know if you have any question or not.
Well, just to abstract it a bit, and I'm sorry for my ignorance, but I always wanted to play around with this stuff, but I never had the chance all the time up until now. You are connecting some input-output devices, sensors, or whatever to your Arduino in specific pins. These pins have a number, and then you are coming here and you are setting up these pins with a name or whatever, you're defining them, and then you are playing around with that. You are reading data from the pins, low highs actually, or a sequence of low highs, and then you are sending data to some pins in order to have some results. Okay.
Yeah, perfect. So now it's the time to open our serial monitor. The distance is this. Here is this number I told you before. Yes, and now I will put my hands and it prints this message alarm, and distance is very small. You can see again. You can see it again. Distance equal to 8. The relay open, and the buzzer makes the tone. Okay, and the last I want to show you. Okay, I think that it's okay. If I press a number, it will show it here.
What's the relay doing again? In your setup over there?
Excuse me?
You have a relay or something, don't you?
Excuse me, could you please repeat?
Yeah, there is a device or something that you call relay.
Yes,
What is it doing in this setup there?
It's this. Sorry for the buzzer, I can't.
Okay.
This.
Yeah.
A switch actually, and we can put in this switch and every time my alarm detects motion, this switch, the relay, will open. The lamp will turn on, and then thieves will be scared.
Yeah. Got it. It doesn't play any role now in what we are doing now. It could potentially, you could connect a lamp or whatever you want.
Yes, but when I put my hand, relay make not a tone, a click. I don't know if you can hear it.
Yeah.
No?
That's the switch.
Yes, it's a switch. And now if I put the number 8, for example, it will show in the monitor. So I can disconnect my Arduino because this buzzer it's very okay, and I can show you the relay from here. Here you can put the wires from your lamp, from whatever you want to connect, and because maybe you want to connect something bigger, there are relay on the market that it's bigger. I have this one, this small one.
Super. There are some questions. One is from 50 that the Wi-Fi connection didn't play any role in this sample, in this demo here. And
yes.
Could you send an alarm to the network?
Yes, I have to tell you something. This module, the code of this module is, I think, one next step from this level, because it has many more information there, and I prefer to not show to you, because I think that we will need, I don't know, yes, because we have if we want to this system to connect to the internet, we have to make code for this. Then we have to connect it with the Raspberry Pi. I have it here too, to show to you. And then we have to connect the Raspberry Pi with the Azure. So I prefer to show to you the Arduino stuff and information about the other two. And
We can do it in the future in another event.
Yes, of course.
A more advanced event. There is another question from Abdelmahid. If I use Azure Sphere, for example, should I definitely also use Azure IoT services?
Yes, of course. I had excuse me to find it, a slide for this. You can also use IoT Central or IoT Azure Hub here. Okay, with Central, okay, I have a picture, and this is with IoT Hub. Of course, you have then make whatever you want in Azure, connected to Azure storage, SQL, whatever you want.
Mhm. Another question here by 50 is asking if we can send data directly to Azure from Arduino without Raspberry.
Um, uh, yes, if we connect the ESP, the Wi-Fi module, we can do it. But um, if we didn't connect it, we can, because Arduino haven't a Wi-Fi module by itself. But we need. I talked about Raspberry. I I will show you the reason. Because of this slide, because in a smart house we have many devices. We haven't one Arduino. For example, we have one Arduino for the alarm, one Arduino for the shouters, one Arduino or another PCB. And then we need all of these PCBs, all of these microcontrollers, send data to one gate, to the gateway, and then the gateway to send it to Azure or in other server. So yes, if you have one PCB, you can do it directly from the Arduino Uno or Arduino something else, but we have to provide some Wi-Fi module.
Super. Yeah, it makes sense because it needs to go out somehow, right? To reach Azure. Okay. Any more questions? I mean, most probably, at least me, I will play around with this stuff. It's kind of a fun hobby. Nevertheless, maybe I will never have a very smart house and have my fridge or something do stuff. But anyway, it's fun to play around with this stuff.
Yes,
How can we reach you?
Yeah. Give me 1 minute again to show you. Where is? Yeah. Oops. So this is my. Oops. Sorry. This is my social media. The first one is my LinkedIn, and the second one is my Twitter. My blog coming soon, but I can't share with you it again.
In the
No,
future.
again. In the future, yes.
In the future event.
Yes. So if you have any question, you can send me, and if I can, of course, I will be glad to help you. In my LinkedIn and in my Twitter, you can be informed about my upcoming events. And in my Twitter, you can find cool things about IoT. Um, Moreover, if you like, I'd love to send me feedback about today's event because this is my first steps in public speaking, and I'd love to to be better and better with the time. So uh, if it's not another question, I have I want to thank you. Today, I wanted to urge you to get on the Internet of Things if you like the concept, of course. It takes small steps, and someday you will be able to do whatever you want. Um, Thank you very much for hearing me.
Super. Um, it was a pleasure having you here, and I would also like to thank you and all of us for sharing your knowledge. Since this, as you said, I didn't know they are your first steps as a speaker. I am glad that you chose us to do that. We will gladly host you again in the future. And yeah, thank you very much. It was great. And at least for me, that I was a complete beginner, it was an eye opener, and it sort of created the urge of start doing things. So thank you very much.
Thank you, thank you.
If anyone doesn't have any more questions, I think they don't, because they all thank you. I think we can leave it for tonight, and maybe some point arrange a new event to deep dive in Wi-Fi and more difficult stuff that we didn't see now.
Mm-hmm.
Super. Thank you very much all for joining. We'll try to publish the event tomorrow in YouTube, so you will have at least 24 hours or something to object to that. And I will, if you see that it's your face, I will blur you out or something. Thank you for joining. Until the next event, I don't remember if it is announced or not, but I think it's not. I will see you again. Ciao. Bye.
Good night. Thank you.